Geometry, the sum said that FEC is a tangent. That's why I immediately made myself aware, highlighting it, that this is a tangent. So immediately, first thing that jumps to mind is that that's 90. It wasn't there, I put it there. So why is it 90? Something tangent. No, you don't get the marks. Unacceptable. Guys, you have to know your stuff. You only have 9. Radius perpendicular to tangent. How hard is that? Right? That's why it's 90 degrees. Then also, what jumps out at me is theorem. One that says what? Line from the center of the circle. Bisecting a chord will be 90 degrees. It has to be the right one. It's not line from the center perpendicular. It's not. It's line from the center to the center or bisecting a chord will be 90 degrees on top of it. And then I can go on with my sum, because the first question says, please prove to me that MDCE is a cyclic quad. I'm done. Why? MDCE. Because the opposite angles are supplementary, not because they're equal. They are equal, 90 each, but it's because they're supplementary. That's why that is a cyclic quad, right? So I'm done with my first question, and I haven't even gotten to, let's get through all the theorems. So if I do that, first step I did was say that E1, and there wasn't a 1 there. Are you allowed to make it a 1? Yes. And speak about E1 here, because I can see on your sketch. And the same here with D1. I'm also going to say that's 90 degrees, and then explain why. Why is it 90 degrees, this one again? Radius perpendicular to tangent. And then why is this D1 90? Let's get the right reason. Line from the center of the circle that bisects the chord will do what? This. This is what it does. Are you with me? Now we've got to say, but then it's a cyclic quad. And my reason says why? Because opposite angles are supplementary. Usually what do we say? It's the converse of opposite angles are supplementary for a cyclic quad. That's why it is a cyclic quad. 4 marks. Was it 3? 3 marks. So I think it would have been 2 marks for that, because that's the most recent one. And then maybe 1 for that reason. No, I don't think so. There has to be another one here. So it's going to be 1 for everything. If you just told me it was 90 and 90, no marks. You have to have the reason. You have to have the reason for both. And then this will only be for the reason, not for this, because that was the question. I will give you a mark for saying that again. All right, let's go through all the theorems that I can possibly see. In this sketch, there's not a lot of other things, but the moment that I do see the tangent, I've got to think of the other stuff as well. Now, 7 was definitely there, the radius perpendicular to the tangent, but number 8, 48.
No.
This is a dead child, this 48. Are you with me? Otherwise, it would have been 2 tangents, and they would both be equal to the point of touch. 2 tangents from a point. Why haven't you written these 9 underneath each other and put it behind the toilet door yet? So that you can keep repeating it when you're sitting there doing nothing. Line from the center of the circle perpendicular to the chord. Number 2, angle at the center twice the angle at the circumference. And when you're looking for it, also look for the skew ones. And look for the bent in one. If you're not looking for it, you won't see it. Number 3 was the angle in the same circle. But you need the diameter for it, so it's not here. Is 90 degrees. Number 4. Bow tie. Angles in the same circle segment. Do you see bow ties? 5 and 6. Cyclic quads. What do they do? We did use that, but the opposite one. Opposite angles are supplementary. Exterior angles. I could have used that. If I had said this one is 90, I could have said exterior angles equal to the opposite interior one for the reasoning here as well. What's the other reason for proving a cyclic quad? Except for those two, opposite.
They all touch the circumference.
No, not that they've all touched the circumference. That's never going to be the on. It's the first thing, but I won't ask you is it, and it is. Okay? It's the bow tie. The opposite of angles in the same circle, segment. So if there's a bow tie happening, those 4 points are cyclic. Those are the 3 reasons for proving a cyclic quad. Right, so 5 and 6, opposite angles, exterior angle. And then 7, 8 and 9 was my tangents. We've done. Radius perpendicular to tangent, the part here that's not there, and then usually 99% of the time if I give you a tangent it will be tan chord. It wasn't here. One of those percentages, it wasn't here. That I can use an angle between the tangent and a chord equal to an angle in the opposite circle segment. Why not? Because it has to be a chord. A complete chord going from there straight all the way, even if it is a diameter, it doesn't matter. It has to be a chord, and there was no chord. So get to your Nernst theorems. Second part of this question said, prove that MC squared is MB squared plus DC squared. What does this remind you of? Oh, I'm so glad. And it's also 3 marks. Second part of this question. If I have to do all those squares, it does remind you of Pythagoras. Pythagoras, is it available here?
Yes.
Why? Do you see the 90s? But now which triangles? Because now this is not just straightforward. It is definitely Pythagoras, I think. But now let's start to look. They've got MC squared. MC squared sounds like science. MC squared, do you see it? They've got MB. Okay, that's a bit of a problem because that's definitely not one triangle there. Because there's too much stuff happening on the right hand side. So let's see. MC is there. MB is there. They were talking about DC. And they're talking about DB. Little PC here. Okay? So now, don't you think we should try 2 triangles maybe? Now this is the sorting out stuff. If I want MC square, I can work in which triangle with Pythagoras? This one? No, it has to be MDC. Let's see if we can get there. Now I've got the crib note there. That's where I need to get to. If we start with MC squared, what will it be equal to according to Pythagoras in this triangle MDC? And it would be a good idea for you to say, listen marker, I'm in MDC now. MC squared is equal to MD squared. Shucks, it's not the same. But it's going to have to at some stage become something I can make a relationship with. So MC squared would be equal to MD squared plus DC squared. Well, okay, that's fantastic. DC squared is at least there, but that's it for Pythagoras there. So there's got to be something else in which I can make a relation with this. Relations can be something like wherever there's an AD, I can substitute it with a DB because they're equal. Wherever there's a radius like MB and ME, I can replace the ME and the MB with each other. Is it making sense what I'm saying? So we're trying to search, this is not level 1, trying to search for some sort of a relationship between the stuff. You're not sitting still. So in another triangle, also trying to work with that, I'd like to get to more of the squares. Maybe we should try this one. But ME, I don't see any ME. EC, I don't see any EC. Are you seeing why I'm eliminating? I don't think I'm going to work here. I don't think. Let's try. Which triangle? MB, D, because we've done C. MD, B. This one. I'm going to be able to look at MB squared. At least that's there. MD is again not there. DB is also there. It's got stuff in that I like, that I want, that I'm looking for. So let's say MDB square would then be MD square plus DB square. Again with Pythagoras, is it necessary for you to write reasons? Yes, geometry, always. Okay, but that's now it. Is there not some way that I can make a relationship between these two? Are they connected in some way? What? Lisa? You seen this?
Yes.
Let's write them both as MD squared. Or, well, you don't have to, but let's try and do this one and say, if MD is 11, it'll be MB squared minus DB squared. Do you agree? This is an equation. Why would I want to do that? Because now I can take this one, and I just chose one of the two. Doesn't matter which one. And I'm going to substitute it back into that one, like simultaneous equations, right? Because they've got a relationship. That MD square and that MD square is the same MD square. So I can substitute this with what? Or I can substitute that with this. Okay? If I go, let's do it like we do in algebra 1 and 2, and I say let's take 2 and put it into 1. So this is going to go there. So it's going to be MC square equal to, what must be here? MB square
minus
DB square. Then there's still a DC square, and it's finished. It automatically got there. Let's see. They wanted MC square equal to MB square plus DC square is just at the back minus DB square is just in the front. You see it happening? For exam purposes, always keep the marker happy and write it the way that they wanted it. So write MB square plus DC square minus, because you're just swapping it around. Did you prove what they wanted you to prove?
Yes.
Okay. Without saying it is, you got there. This was a reason, a legal reason, Pythagoras. This was a legal reason, and you got to a connection. Level 1? Okay. Last part of the question said, calculate CE if AB is 60, AB is 60. Now they're giving me some, okay. Please don't do the whole sum at once. Don't start off in the beginning of the sum and read there that AB is 60 and start using that in the beginning. If they only give it to you here by question number 3, you're only allowed to use it from question number 3. Are you with me? You couldn't go from the start and say AB was 60. What would it help me if I know that AB is 60? Each of them is. Do I need to write that reason? It was given. It's not that it's the theorem that you're using. It's given that they're equal, so if the whole thing is 60 and half of 3, you don't need to write that. ME is 40. So they're giving me this piece. ME is 40. Also, they give me BC is 20. BC is 20. And what is the question? Find CE. This is my question. What pops to mind? Pythagoras. You agree? Well, why can't I just immediately do Pythagoras? Because I only have one side. Please don't forget that you've done lots of trig. Solving sides, solving angles, etc. You've done lots of trig, right? So don't forget you can use all that stuff as well. We are going to use Pythagoras, but don't forget that you can also use that. So if I can find this side, I'll be able to get that side. But now, I'm going to have to do a few Pythagorases here. Don't you agree?
Yes, sir.
But there should be a connection, because things to me look like they're not enough. There's not enough. Say which one? Fantastic. She's got it. M, B is a. So we've gone through all of the 9 reasons, but don't forget that in your circle, radii are always the same. So that PC there would also be 40. I'm not going to use it because it's a bit of a bit. But that length there should also be 40. All the radii in this circle should be 40. And I needed that to be able to have a start. Because in this triangle, if I've got 40 and 30, I can find this one. Is it 50?
No, 20.
Okay, remember the golden triangle, 30, 40, 50? It's not. It's 30 and 40, but 40 is not the hypotenuse side. Oh, no. The hypotenuse side should be the 50, so this can't work. Not with 30. So you wanted to say that the shorter side is 50. Okay, so it's going to not be 50. You're going to work it out, then we've got this side and this side in the bigger triangles. Remember, because I can't work with that one, because I don't have enough information to do sin rule, cos rule. It's not a right angle triangle, can't do Pythagoras. So I'll use the bigger one, find MD. Once I've got the MC, once I got the MC, I'm done. So do I have to do 3 Pythagorases here? Yes, sorry, you're going to have to. Okay. Okay, so let's have a look at the Pythagorases. First in MBD, we're doing to find MD. Why do we need MD? Because then we're going to go for the bigger triangle to find MC. Once we got that, we've got 2 sides and we can find the actual one that we're looking for. So finding MD, it's 40 square minus 30 square, which gives me root 700, which is 10 root 7. Can you put it into decimals? Yes, but why wouldn't you? This is more accurate than saying, I don't know what it is, whatever, comma, whatever. Because that's rounded off, so it's not so accurate. So if you have a choice, don't take it to decimals, especially if there's some more stuff to come. Then once I know that this is 10 root 7, I can now work in this triangle, because I have this side as 50. 50 and 10 root 7, and it's the sum of them that gives me the hypotenuse side, grade 8, right? So then I get to my answer of 40 root 2. Calculator. Square that, please don't get confused. Put it into your calculator. If you had to do it with your own brain, root 7 times root 7 is 7. 10 times 10 is 100. 100 times 7 is 700, and that's 2,500. That does give you 3,200. Test your brain a little bit when you're at home, but in a test, you do everything with a calculator, even 2 plus 2. Okay. Then once I've got that, I'm in triangle MEC, so the hypotenuse side minus the shorter side will give me EC that I'm looking for. Work out the calculator. So that means if EC is 40, then this triangle was a which means what? Angles are the same. How much? 45 each. They didn't ask that, but are you with me? Since they're both 40, this should be isosceles. Since I have 90, they will both be 45. Okay.